Hey guys, how's everything going? This is JSer, who is not good at algorithms. I'm making a series of videos about the sort algorithms. Hope you can enjoy. I've already done the bubble sort, insertion sort, selection sort, and all of them run a little slow. And today I'm going to try the merge sort. So the merge sort is an idea of divide and conquer. When we are given a large amount of input, why not we just split them into two halves and tackle them separately? And after that, we just merge the result into one, right? So let's put the time complexity at the end and start writing the code. So the idea is simple: split them into half and recursively, and finally merge them up. So I'll create a merge sort. It receives a list, and we choose a middle index, right? Which is based on the index 0, 1. So the middle should be 0. Math floor list.length minus 1 divided by 2. Const left half, first half. List slice 0. And we will return merge, right? After all of these two halves are sorted. Well, the ending condition should be if there is only one element, right? So yeah, and now we tackle the merge. To receive two lists, both of them are sorted. So we need to merge them into one larger list. Well, it's simple. We use 2 pointers and pick the head, the smaller head, and push into the result and do it recursively. If the first one is smaller, we push the first one. Don't forget to move I to the next one. For the other case, of course, we push list to J. When this while loop is done, there might be some items left, so we will continue. If list 1 is left, we just push, right? Okay, if list 2 is left, we push. So, and by this, we will receive a merged result. And at last, we could return merge sort nums, right? So it's done. Cool. Let's submit. Yeah, you see, actually we run much faster than the other two sort method. The insertion, the bubble sort, the insertion sort, the bubble sort, and what the sort? The selection sort, bubble sort, insertion sort. Yeah, better than those three. So why? Let's analyze the time and space complexity. So the time used in this merge sort actually have two parts. The first one is merge. The other one is sort, right? So for merge, obviously for this one would be linear time, right? The sum of the total length of list 1 and list 2. So it's linear time. And then for the sort, you see at last, actually, we only sort we didn't do any sort actually. At last we will be to only one list with only one element. It's just a constant time, right? So how many times this merge happens? Well, this sounds a little hard to understand, but let's draw a tree. So this is merge sort, right? And then we have two merge sort. Of course, the merge is over there. Suppose this is the last round, right? This all with list with only one element. So this will be constant. So how many are there? Well, suppose the input nums is n. This actually is n. So this is the only sort that happens actually for each above. It's actually merge, right? It's not sort, it's merge. So for merge, it's the length of both lists. Actually, you see, for each layer, it has merge n items, right? Though the tree node is less, but actually the list will be longer. So here, though it's only one element, one node, but actually there were very long lists. The length of the list is still n items. This is just a 1. So you see, the time would be actually n times a layer, right? So every time we divide it by 2, so how many layers are there? It's actually log n, right? So this is a time complexity, a space. Of course, we use an array to keep track of the result. For each round, it will be recycled, so actually they will be using linear time. Right, comparing to the bubble sort or insertion sort, this is much better, right? For the other 3 sorted method, it's always n to the cube. So this is much smaller than n cube. Not cube, it's a square. Cool. So is this stable? You see, for merge sort, we only actually merge them without swapping, swapping one element so very far away, and the order is respected, even if one element, even if 2 elements are in a different half. When we merge, we will always respect the first half, so it's stable. Okay, so that's all for merge sort. Divide conquer is actually very important approach, but I am not very good at it. I hope in the future I could think more about divide conquer when I meet the complicated ones. So okay, that's all for today. See you next time. Bye bye.